Hello. In this video, we will see what do you mean by canonical form and also see how to convert a given sum of product or product of some expression into canonical form. Let us start. For any digital system, we usually write its output expression in simplified form, whereas canonical form is a way of writing the output expression in such a way that each term of the expression will contain all input variables. So there are two formats, canonical SOP or canonical POS. We will take example in each type and see how to convert them into a canonical form. So the example that we have here is function f is dependent on input variables ABC, and the simplified expression that we have got is AC or AB or BC. So we have to convert this expression into a standard sum of product, that is canonical form. So you basically have four steps. First step is you find the missing literal in each term of the equation. So let me just write down the expression here. AB or AC or BC. So in the first term C is missing, in the second term B is missing, and in the third term A is missing. So we have identified the missing literals in each term of the equation. So step 1 is done. So step 2 is AND each product term having missing literal with term formed by ORing the missing literal and its complement. So this is based on the identity that A or A bar is always equal to 1. This is a boolean identity. So according to step 2, what we have to do is step 2, in the first term C was missing, so you will AND it with the missing literal and its complement. Similarly, in the second term B was missing, so you will AND it with B or B bar. Similarly, in the third term A was missing, so you will AND it with A or A bar. By ANDing each term with the missing literal and its complement, you are not modifying the equation, because C plus C bar or B plus B bar or A plus A bar is 1, and when you AND any variable with 1, you will get the variable. So step 2 is done now. Step 3 is expand the term by applying distributive law. So that is, I have to multiply each term that is outside the bracket with each of the term that is inside the bracket. So this will be ABC or AB C bar, and this will be ABC or AB bar C. This will be ABC or A bar BC. So step 3 is done. Step 4 is you have to omit any repeated product terms, because A plus A is equal to A. This is also a boolean identity. So you can see ABC is repeated once, twice and thrice. So you can write it only once, whereas A B C bar is present only once, A B bar C is also once, and A bar B C is also present only once. So step 4 is ABC or ABC bar or AB bar C or A bar BC. So this is your canonical form of AB or BC or AC. So you can see that each term in the canonical form contains all the input variables, that is ABC. Next we will see how to convert a product of sum expression into a standard product of sum expression, that is its canonical form. So we are given a function f dependent on input variables ABC, and this is a simplified product of sum expression A or B and B or C and A or C. So these are the steps that we need to follow to convert the given product of sum expression into a standard product of sum expression, that is its canonical form. So step 1 remains the same, that is you find the missing literal in each term of the expression or the equation. So step 1, A or B and B or C and A or C. So from the first term C is missing, and from the second term A is missing, and from the third term B is missing. So we have identified the missing literal. So step 1 is done. Step 2 is or each product term having missing literal with term formed by ANDing the missing literal and its complement, because A and A bar is 0. This is a boolean identity. By doing step 2, it says we have to OR each term with the term formed by the missing literal and its complement. That is, you OR each term with the term formed by its missing literal and its complement. Similarly, we'll do it for the other terms. So this will be A bar or B or C, and the third term will be A or B bar or C. So step 2 is done. Step 3 is expand the terms by applying x plus yz is equal to x or y and x or z. So this can be proved from Boolean algebra. For now, just keep in mind that x or yz can be written as x or y and x or z. If I apply this identity on the first term by assuming that a plus b is x, c is y, and c bar is z, then the first term gets reduced to x or yz, which can be written as x or y ANDed with x or z. So x in this case was a plus b, y was c. Similarly, x was a plus b and z was c bar. Now when you apply this rule on the second term and the third term, we will get a or b or c ANDed with a bar or b or c. For this term you will get a or b or c ANDed with a or b bar or c. So step 3 is done. Step 4 is you have to omit any repeated product terms because a and a is a. Let me write down the term that we got by expanding the first term here. So this was A or B or C and A or B or C bar. So this was from the first term, this was from the second term, and this was from the third term. So step 4 was omit any repeated product terms. So you can see that A or B or C is repeated once, twice, and thrice. A bar or B or C is present only once. Similarly, A or B bar or C is also present only once. And also A or B or C bar is also present only once. So as a result of step 4, you will be remaining with A or B or C and it with A bar or B or C and it with A or B bar or C and it with A or B or C bar. So this is the canonical form of the given expression A or B and B or C and A or C. Step 4 is also done. Thank you.